feel free to, you can leave the class. Okay, na? Yeah. Okay. Good evening, everyone. Chitradurga team, I hope you people understand what I'm saying. Ki, I'm so sorry. Ranga Reddy is also joined. Right. Okay, so I'm extremely sorry for the whatever the issues are happening. Here there is a power cut issue. So I will take 15 or 20 minutes. Then I will continue tomorrow for sure. I'm extremely sorry for this. So the reason I tried my level best to keep the charge, but I'm unable to do that one. So what I'll do is I'll just revise the things what we have done. And tomorrow also we are having the class. Definitely tomorrow I'll extend another 10-15 minutes. Okay, na? Thank you so much for your understanding. If you are clear with this, please let me know through the chat box, or else you can unmute and you can say it's okay, sir, fine, like that. I don't know how many minutes it will come. So last time we are discussing about Nernst equation. So the basic fundamental of the Nernst equation is this one we have seen, and equilibrium constant also how do you do we have seen, and how to calculate the pH directly by using the formula. So today we are discussing about electrolytic cell. Okay. Yeah. So electrolytic cell, basically in electrolytic cell, what do you have to do? So there are important Faraday's laws. So the important law for electrolytic cell, why we need to read about electrolytic cell before I'm going to tell you. So here there is an impure cathode. Okay, na? So here there is an impure electrode. This is my impure electrode. Okay. So this impure electrode you have connected with a pure electrode. You have connected with a pure electrode. Okay, na? So then further there is what is going to happen at anode. Okay, these which is anode and which is cathode here. Now the question comes, which is anode and which is cathode. So this will become my anode and this will become my cathode. Okay, na? So here you can see anode is connected to the positive charge and cathode is connected to the negative charge, right? So in this case, whenever the impure copper cathode I have kept here, okay, what will going to happen? Impure copper anode, the impure copper ions are trying to move inside the solution. Okay, so these copper ions are moving inside the solution, and these copper ions are coming out of the electrode and moving towards the cathode. So they are moving towards the cathode. So what will going to happen when they are moving towards the cathode? There is a deposition of copper is taking place. Here I have mentioned there is a deposition of copper is taking place. In the anode, the copper will going to lose Cu plus 2 ions, and at cathode, these Cu plus 2 ions will going to collect 2 electrons or consume 2 electrons or gain 2 electrons, and the deposition of copper takes place on the surface of the pure copper. So pure copper will be at cathode and impure copper at anode. So indirectly, this electrolysis process is helping for the product formation, like copper formation on the cathode. So deposition of a copper on the cathode is explained by the Faraday's law. Now see how the Faraday's law works. So Faraday is a scientist. He said that whatever the amount of deposition is taking place, whatever the amount of copper deposition is taking place, so this is occurred during the electrolysis. What is the meaning of electrolysis? It's simply, by using the electricity, you are breaking the electrolyte. So whenever you are breaking the electrolyte, So what will going to happen? It will going to break as ions. So those ions are consuming 2 electrons and depositing at the cathode. So how much amount of copper is deposited or liberated at the cathode is depending upon how much current you are passed, or indirectly we can say how much charge you are passed. Okay na? So we have seen that we have connected with a battery and we are doing the process. So how much current or how much charge is passed so that the deposition of copper takes place on the cathode will occur. So now see step by step. So the weight of copper deposition is directly proportional to the charge which we are produced or which we are doing. So now we already know charge is nothing but time into current. So we already know that charge is nothing but time into current, or we can say sir, current into time. So if anybody is asks you what is the meaning of a charge, charge is nothing but the current passing. Let's suppose 2 ampere current is passed in 30 minutes. So the charge is nothing but 2 into 30 minutes. You need to convert them into seconds. That is 1800, okay, ampere per second. Okay na? So ampere second, not per second, ampere second. So this is nothing but coulombs only. Okay na? So charge, if anybody asks you the current, okay, within the span of 30 minutes, if you are passing a current of 2 ampere, that is nothing but its charge. So that is W is directly proportional to I into T. And further, after removing the proportional, I am keeping a, I think you people can hear the voice. Okay. Yeah, your battery is running low. I am so sorry, guys. Okay, let me stop the streaming first. I'll stop the streaming. Then at any time it might be happen. Like just a minute.